So we've kind of like dived into exponents lately. We've been using fractional exponents, and before we were doing positive and negative exponents. But what this video is about is exponential equations, but instead of having it be like x squared or x cubed or something like that, this is where the variable that we want to solve for is in our exponent. Okay, we need to figure out how to get it out of the exponent so we can solve for it. All right, so our title, solving exponential equations. All right, please take notes while watching this, because this is not, we're going to practice this next class, but I don't want to have to give notes on it next class. Okay, so we're going to be solving exponential equations, and then this is with the variable in, not is, in, whoop, with the variable in the exponent. Okay, so what do I mean by that? I mean, like, if I have 3 to the x plus 2 power is equal to 9. Okay? We can't just, subtract 3, or we can't just subtract 2, because right now this x and this 2 are stuck up in that exponent. We need to get them out of that exponent in order to start moving stuff around, okay? There isn't, a reciprocal exponent that we could take like we were doing last time, because that doesn't really help us either. Okay, the reciprocal of x plus 2 is 1 over x plus 2. Alright, don't write this. So that would get rid of my exponent in here, but then I'd have it over here, and I'm still going to have an x in my exponent. So that doesn't really help. None of the strategies that we know so far can help us take the variable out of the exponent. And that's what we want. Okay, so let's take a step back and talk about something that's super basic. We're going to take a super basic idea, and we're going to use that to help us solve for these exponents. Okay, say I have some number b. All right, let b equal some number. Okay, and I'm also going to let q equal a number. Doesn't matter what kind of number. It could be positive, it could be negative, it could be a fraction, it could be a decimal, whatever. Okay, so I'm letting b equal a number, I'm letting q equal a number, and I'm going to let p equal a number. Ooh, not a pumber, a number. Oops. Okay, and p and q are kind of random, but I picked b for a reason. I'm going to let b be my base. Okay, so let's see if I have b as my base, and I'm going to raise that to the q power. Okay, so I have some number b, and I'm going to raise that to the q power. And I'm going to tell you that that is equal to the same b raised to the p power. Okay, so I've got b to the q is equal to b to the p. Well, hopefully everyone right now is saying, well, that would mean that q and p are equal. Doesn't that make sense? If I have like 2 to 1 power and I say that's 2 to this other power, those powers have to be equal. Alright, so if I tell you that b to the q is equal to b to the p, then it just is common sense that q is going to have to equal p. So that's going to be our strategy when we're solving these exponential equations. We want to get it so these numbers have the same b, so they have the same base. Because if we can do that on both sides of our equation, then we can go ahead and set those exponents equal to each other. Okay, so the name of the game is that we want to have the bases the same. Because if the bases are the same and we have an equal sign, then we know that those exponents have to be the same. Okay, so let's do an example. Example 1. Okay, let's solve. First, I'm going to give you 3 to the 3 minus 2x power. And I'm going to tell you that that is equal to the 3 to the minus x power. Okay? Those have the same base. They both have a base of 3. So if 3 to the 3 minus 2x power is equal to 3 to the negative x power, we can assume that that means that this exponent has to be equal to this exponent. So we're going to say, well, duh, that means 3 minus 2x is equal to negative x. We can go ahead and solve. Add 2x to both sides. 3 is equal to x. Done. Answer. And we can go ahead and check that. So we always check in our original. So that's going to be 3 to the 3 minus 2 times 3 power. This is 3 minus 6 up here. Oops. Getting ahead of myself. And that is in fact negative 3. And you know, you could stop there, but I'm going to come up here because remember, if we have a negative exponent, we can make it positive by taking the reciprocal. So 3 to the negative 3 is really equal to 1 over 3 to the positive 3. I was stuttering for a second. And so we get 1 over 27 is equal to 1 over 27, and everything is good. Okay, so because I had the same base, I could set those exponents equal to each other, and I could go ahead and solve for x. Let's do another example. How about, let's do, what do I want to do? Okay, example 2. Let's do 6 to the negative 2x is equal to 6 to the 2 minus 3x. Here, these two numbers have the same base. Alright, they both have a base of 6, and they're equal. So that means that negative 2x has to be equal to 2 minus 3x. So I'm going to go ahead and set those equal to each other and solve for x. When I do that, I'll add 3x to both sides. And you end up getting that x is equal to 2. Okay. And then, just like before, we can go ahead and check. So that would be 6 to the negative 2 times 2. This is 6 to the negative 4 is equal to 6 to the 2 minus 6. But that's just 6 to the minus 4 equals 6 to the minus 4. Okie doke. But those are pretty simple because they already have the same base. Sometimes we need to do some work to get our equations to have the same base. Okay, so let's take a look at this example. I'm just going to draw a line down the middle of my paper. Let's do example 3. It's a horrible E. And let's do 10 to the negative 2x is equal to 1 over 10. Okay? Right now, this isn't like the first two examples, okay? In the last example we did, they both had a base of 6. In the first example we did, they both have a base of 3. Here, not so much. On the left-hand side, I have a 10, but on the right-hand side, I have a problem because I have 1 over 10, okay? We need to think of a way to rewrite this equation so they both have the same base, and then we can go ahead and set our exponents equal to each other. Okay? Now, if I look at the left, 10, I can't really rewrite. You know, 10 is 10. I can't break that down. You know, I can't rewrite it as like 2 squared or 3 cubed or whatever. So, unfortunately, this 10 to the negative 2x is just going to kind of have to stay. Okay, now if I look on the right-hand side, I have this 1 over 10. Or you know what, just for fun, I'm going to rewrite this as 1 over 10 to the first power. Okay? Now, hopefully we're remembering that with this 1 over 10, I can rewrite 1 over 10 as just 10. Okay, but since I flipped it, since I took the reciprocal, I need to change the sign of my exponent. So now instead of 1 over 10 to the first, I'm going to have 10 to the negative first. Okay, using those properties of exponents that we know. And then, boom baby, same base, we can set these exponents equal to each other. So I will say that negative 2x is equal to negative 1, or x is equal to 1/2. Okay, and if we go ahead and check that, that's going to be 10 to the negative 2 times 1/2. And we check it in the original, so we're going to set that equal to 1/10. Well, negative 2 times 1/2 is negative 1. And 10 to the negative 1 we can rewrite as 1 over 10 to the positive 1. And boom, baby, there we go, it checks. Okay, so sometimes it does take a little bit of work to get these common bases. Let's do one, maybe two more examples. Let's see how I am doing on time. Okay, we're going to do one more example and I'm done, mostly because I have a class in here. Okay, example 4. Let's do 9 to the negative 3x times 9 to the x is equal to 27. Okay, looking at this, they definitely don't have the same base, but first off, I see that if I have 9 to the negative 3x times 9 to the x, well, those have the same base, so I can combine those and add the exponents. That's really 9 to the negative 2x is equal to 27. Okay, so I just simplified a little bit. I haven't actually done anything with the bases. Now, those definitely don't have the same base. I have a 9 and I have a 27. I need to somehow think of a way that I can rewrite 9 and 27 to both have the same base. So I need 9 and 27 to both be some number that's the same, raised to a power. Okay, and if I look at 9, 9's pretty easy. A lot of us know that 9 is really 3 squared. So I'm going to rewrite 9 as 3 squared, and that is to the negative 2x power. And 27, we should know that 27 is equal to 3 cubed. Okay? Now, right now, we're almost in business because now we have the same base on both sides. We rewrote this equation so both sides have a base of 3. Okay, but I do have one itty-bitty piece of work. I have a power raised to a power, so I multiply those exponents. So this is really 3 to the negative 4x is equal to 3 to the third. And now, both sides are simplified. Both sides have the same base. So now I can take this exponent and set it equal to this exponent. Negative 4x is equal to 3, or x is equal to negative 3/4. Okay, this one took a little bit more work to get the same base. Okay, and unfortunately I can't really give you guys a trick to always, know what base to look for. This really is dependent on you guys kind of seeing and knowing your facts of how to rewrite something as a square or a cube, or doing a little bit of legwork with your calculator. Okay, we'll talk about this more next time, but make sure you took these notes down, and like I said, we'll do some more practice next month.